So we are expected to do some of these without graphing. So to do this, we're going to have to guess at the first factors and then break it down and solve the quadratic. So here we have a fourth degree. So we know we have to break this into 4 parts if we can. So we're going to have to guess. So I'm just going to write down my possible guesses here. Plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 10, and plus minus 15, plus minus 30. Okay, I'm obviously not going to check those ones, but we should check, 1. Okay, if I plug 1 in, I get 1 minus 6 minus 4 plus 39 plus 30. That's not equal to 0. Negative 1. We get 1 plus 6 minus 4 minus 39 plus 30. This doesn't quite add up to 0. Okay, so I've got to keep going. So negative 2, I'm going to get 16 minus negative, so it's going to be 8 times 6 is 48. So this is going to be 4 times 4, 16 minus 78 plus 30. Well, the 16s cancel. 30 plus 48 is positive 78. So this is going to be equal to 0. So this is one factor. Okay, so I've got my x plus 2 factor here. Okay, so I've got 1. I need one more. So I've got lots of possibilities here. So I could just kind of go up incrementally. And we might have to guess and test quite a few here. I could try negative 2 in that, but I'm going to actually just try positive 5 because I'm pretty sure that one's going to work. Okay, so when I test positive 5, I'm going to end up with, that's going to be 625 minus 6 times 125 is going to be 750. Okay, so 750 minus 100 times 25 times 4 is 100 plus 39 times 5, that's going to be 195. Okay, if I'm not mistaken, yeah, 195 plus 30. Okay, so adding this up, this is negative 850. Here I add 95. 5 to, this is 5 to what, 625 is 630, plus 90 is 720, plus 100 is 820, plus 30 is 850, so this is going to be equal to 0. So I have my second factor, x minus 5. Okay, so at this point, I can break down this remaining polynomial. Okay, so I'm going to have my division 1, make sure I have all the powers, negative 6, negative 4, 39, 30. I'm going to use that plus 2. So I'm going to have 15. Okay, so I get a remainder of 0 here. Do it again. Okay, I'm going to use a minus 5 this time. So I get minus 3, you get plus 15. Okay, so there's my 0. And I end up with x squared minus 3x minus 3. Okay, so there's my quadratic factor. Just going to put it into there. So this is my quadratic factor, x squared minus 3x minus 3. So I'm going to try factoring that. And as I try to factor that, I'm thinking of two numbers that multiply to negative 3 and add to negative. There are no two numbers, so this is not factorable. Okay, now this does happen to have a solution. It's an irrational solution. Okay, it's kind of hard to tell, but we could always test it in our discriminant. This happens to be irrational. We may end up with a non-real solution here as well. But it's important to know that you do have to make the distinction, because if you were asked to factor this, this is good enough. If you're asked to solve this, we could actually solve this still by putting this into the quadratic formula. So let's say hypothetically, this was, say, equal to 0. Okay, the question doesn't say that, but it says, let's say hypothetically it's equal to 0. I would end up with the solutions. Okay, x equals -2, x equals +5. Then I would have to solve the other x using the quadratic formula. So it's going to be 4 times a times c. So it's going to be minus b squared minus 4ac all over 2a. So this ends up being, it's going to be 12. So 3 plus minus square root 21 over 2. So if this was an equation equal to 0, although it's not factorable, it is irrational. So we do have solutions for it. Okay, if this was non-real, then we couldn't actually solve this part. But being irrational, we can actually solve this using the quadratic formula. So be mindful of that if you're being asked to solve versus factor.